All right, good morning, everybody. Thanks for joining. Today, our topic is programming inputs and outputs on an NXF4000 or a PPC4000. So let's get started. So if everybody could try to remember to mute their phones or their connection, that would be great. So first of all, inputs and outputs. The NXF4000 has the following inputs and outputs. So we have 15 programmable line voltage digital inputs. We have 3 programmable line voltage digital outputs, 5 programmable 4 to 20 milliamp analog inputs, and 1 programmable 4 to 20 milliamp analog output. And that can be raised to 3 if the NXCES VFD card is fitted, and that's typically used for controlling a VFD. The PPC4000 has the following inputs and outputs. So it has 10 programmable line voltage digital inputs, 5 programmable 4 to 20 milliamp analog inputs, and 1 programmable 4 to 20 milliamp analog output. Also can be bumped up to 3 if the NXCES VFD card is fitted. So for the physical wiring on the NXF4000 digital inputs, the inputs are rated for the line voltage at 1 milliamp of current. So the line voltage could be 120 or 230 volt depending on if it's an North American or European control. And these are only intended to monitor a voltage, such as for a switch or a status. And the terminals are on both the P13 as well as the P15 connectors, and they both reference the neutral that's connected to P3 terminal L2. So you can see P13 houses digital inputs 1 through 12, and P15 has 13 through 15. The PPC4000 digital inputs are similarly rated for the line voltage at 1 milliamp of current, so very similar. But these are all on the P13 connector and reference the same neutral on terminal P3 L2. So with the PPC4000, there are only 10 digital inputs instead of 15, and you'll note that the order of them is different than it is with the NXF4000. On terminal 1, it's DI10 instead of DI1, so it's a slight difference. The NXF4000 digital outputs are rated for the line voltage with a load of up to 480 VA. So these outputs are not safety rated and are intended for use to monitor or provide a function that is not critical to operation. So these terminals are all on the P5 connector and reference the neutral on terminal P3L2. So if you want to have dry contacts out of these outputs, you need to add a relay to connect to them. So for both the NXF4000 and PPC4000 analog inputs, they are 4 to 20 milliamps and can work with either syncing or sourcing transmitters. This means that either the NXF4000 or PPC4000 can supply the loop power, or it can come from an external source. If the NXF4000 is to supply the power, which is called sourcing, the 2 wires of the transmitter would connect to the plus 24 volts DC and to the applicable sensor input that receives the 4 to 20 milliamp signal. And this is how the FireEye supplied transmitters are typically wired. If the power is from an external source, which is syncing, the 4 to 20 milliamp signal is connected to the applicable sensor input, and the common of the external power supply is connected to the plus 24 volt return. So multiple 24 volt DC and 24 volt return terminals are provided so that you can connect multiple sensors more easily. And those terminals are all located on the P11 connector. So the outputs for both the NXF4000 and PPC4000 are also 4 to 20 milliamp. And there's one output provided on the P11 terminal block that references 24 volt return when connecting to an external device. There are also 2 outputs on the P2 terminal block, which is the terminal block for the VFD, that references one of the common terminals 7 through 12 on that terminal block when connecting to an external device. The outputs on P2 are only available if the NXCES VFD card is fitted and when those outputs are not being used to connect to a VFD. So to program, there is a menu for digital inputs. There's a menu called Digital Input Setup for both the NXF4000 and PPC4000. So you press the right arrow or the next key to enter the submenu, and each digital input will then have its own separate submenu from there. So when you're setting the function, the use item refers to the assignment of the digital input. So you press the modify save key to allow editing of the use, and then other parameters such as assignment or action will be explained further with each individual choice. So now we'll go through the different choices you have for the digital inputs. So global inputs. There are many other input choices. Hold on a second, I missed a slide. So burner control. The first choice for setting the use is to burner control, and that allows the digital input to be used to start and stop the control in the same manner as the keypad on-off key. So when you choose burner control for the use, assignment is set to NA, since this is a global setting that is not affected by any profile selection. So it'll work on any profile. Action can be set to AND or OR. Setting it to AND means that this input has to be on, along with any other set to the same function, and that also includes the keypad burner on key setting. So setting to OR means that any assigned input or key can be on. So another way to think of it is that AND is like putting multiple switches in series, and OR is like putting multiple switches in parallel. So there are many other global input choices that will work in the same manner as burner control. So for each of these, assignment is not applicable and the action must be set. So some of the other choices are set point to select. So if you apply this digital input, it will force you to use set point 2 instead of set point 1, assuming that set point 2 is properly configured. You also have low fire hold, which forces modulation to low fire, and this can also be done using the low fire key option on the keypad. And again, if you activate the low fire key option on the keypad, then AND and OR will be important, because then if you choose AND, both the low fire hold keypad key and this input would have to be on. If you choose OR, either one of them could be on. Alarm reset would allow a remote reset, and this should only be done within sight and sound of the burner if you're going to use a digital input to provide the reset. And then we have manual modulation, which forces manual modulation mode, and then you use the keypad to set the rate. And this also works in conjunction with the auto manual key option on the keypad as far as AND and OR goes. So some more global inputs. We have O2 trim disable, and this forces O2 trim control to be disabled by temporarily overriding the permanent settings. Force setback will force the setback set point to be used when you're outside of the scheduled time. Setback override will force the setback set point to be overridden when you are within the scheduled time. Force sequence master will force the selection as the master when sequencing is used. And normally if this method is used, the other units will also have a similar connection and they will be turned off. So you'll only turn one on to be the master. And this can also be done using the lead lag key option. And then sequencing off, which will force sequencing to be disabled by temporarily overriding the permanent settings. Track on, when track modulation is used, this input allows the burner to start. So if you're using track modulation, you have to set one of the digital inputs to track on to enable the burner. So in the absence of this input, the control can run to maintain the standby set point if enabled. This input is normally connected to a control system of some kind. So if you do enable standby for hot standby and track on is not enabled, it will go to the standby sensor. Force blower on, and this input forces the output to turn on, the blower output to turn on, and this can be used to provide a purge separately from the program pre-purge or post-purge. Another choice of use for digital input is lockout. So a lockout can be forced by applying line voltage to an input. This can happen at any time in the sequence or in standby. So if you choose for the use to be lockout, the assignment must be used for this selection to specify which profiles this will apply to. So it could only apply to one fuel if desired. So in this case, in the example, I show the assignment as 1. So that means this only applies to profile when profile 1 is selected. The action is not applicable for this choice. And the lockout generated will read forced I01, but you would substitute the digital input number you're actually using. So if it was digital input 15, it would say forced I15, and this will require a reset to clear. And something that isn't in this presentation, to actually pick the profiles, there are dedicated digital inputs for that. So you don't have to assign a digital input to choose a profile. Selecting profiles 1 through 4 already have dedicated digital inputs. So then there's valve proving inputs. So if you want to use valve proving, two different inputs must be assigned to monitor both the normally open and normally closed positions of the switch. And this is the gas pressure switch used for the valve proving test. So the assignment must be used for this selection to specify which profiles this will apply to. So situations that only apply to one fuel can be used. And the action is not applicable for valve proving inputs. And as you can see in the examples, here DI1 is assigned to gas valve proving normally open, and DI2 is assigned to gas valve proving normally closed. So you use two digital inputs for the normally open and the normally closed of this switch. Airflow proving inputs is another choice. The airflow switch can be connected to dedicated inputs to provide both a specific lockout message as well as an airflow switch check that the state changes. If used, two different inputs must be assigned to monitor both the normally open and normally closed positions of the switch. Now this is optional because the airflow switch can also be connected in the safety limit string if desired. The assignment for this is not applicable. It's a global setting. It'll apply to all profiles. And the action can be set to and or, and this would only apply if you were to assign more than one input for this function. So in this example, we have digital input 1 for airflow switch normally closed, and digital input 2 for airflow switch normally open. An input can be assigned for purge hold, which will hold the control and purge indefinitely. So this assignment must be used to specify which profiles that you want to apply this to. And the action also must be set to and or in case you have more than one input assigned for this function. So when you use purge hold, if that digital input is on, once you're in the sequence of purge and you apply this digital input, it will display the message hold, and then IO1 in this case because it's digital input 1. So it'll allow it to stay in purge until you release the purge hold. And you could use this to interface with some sort of external interlock or something like that. There's LGP check, and that means low gas pressure check. An input can be used to monitor that the fuel pressure or supply is sufficient. This input must have voltage during and after MTFI, which is state 13, or a lockout will occur. Assignment and action are not used for this input. So if you assign this input and it doesn't have voltage when it's supposed to, you will get a lockout like the one on the right that says LGP fuel supply. FVES or POC input, that stands for fuel valve end switch, proof of closure, closed position indicator is another name. An input can be used to monitor the position of the fuel valve end switch or proof of closure, and this input must have voltage during and after. It should be before MTFI, that's a typo, or a lockout will occur. So it's checking to be sure that the fuel valves are closed before you get to MTFI. The assignment must be used for this selection to specify which profiles this will apply to, so situations that only apply to one fuel can be used. The action can be set to and or, and that again only applies if more than one input is used for this function. And note, DI15 is set for this function by default. So here in the example, we set DI15 to use for fuel valve end switch or proof of closure. It only applies to profile 1, and if the proof of closure is not closed when it's supposed to be, you will get a lockout, like the one on the right, FVES open, and it will tell you which input it was coming from. There's a run check input, and an input can be used to put the control into check mode. And you might be familiar with run check mode from flame safeguards. When there's a switch, you can switch to put it into check mode. And this can also be done using the run check key on the keypad. This feature must first be enabled from the burner control setup menu, which is a setting called enable run check. By setting this will enable the run check function for 2 hours. So for run check, assignment is not applicable, and the action can be and or, and this only applies if more than one input is used for this function. So you're going to want to set it to or, because if it's set to and, then the keypad key would also have to be pressed at the same time. So when a good time to use this is during commissioning. When you get to the ignition position, you can put it in run check, and then it'll stay there so you can make adjustments to the servos in the ignition position. But you can also use it to hold and purge in different positions along the way. So generic inputs allow a condition to be monitored and for different actions to be taken. So for generic inputs, the assignment must be used to specify which profiles, and so the situations that only apply to one fuel can be used. The action is set to and/or and only applies if more than one input is used for the function. We have an additional option called state that indicates the state at which monitoring of the input begins. The input state determines if the input should normally be on or off. And finally, the go-to indicates the action that should occur when the condition is true. So input state would be 0 or 1 for on or off, and then go-to is what you want it to do. And there's some more detail for that here. So the state choices you have are all. The input would be monitored in all states. After pre-purge, it's only monitored after pre-purge has completed. High fire purge only, the input is only monitored during the high fire purge. After low fire purge, the input is only monitored after the low fire purge has completed. PTFI, MTFI, the input is only monitored during the PTFI and MTFI states. And MTFI auto, where the input is only monitored during the MTFI and auto states. So if the input is not does not continue to be true, then you have different go-to choices. What do you want it to do? So the first choice is to lock out. There will be a lockout when the condition is true. Standby for 1 second or 3 seconds. So the control will return to standby if the condition is true for more than that amount of time, 1 or 3 seconds. And lastly is alarm. There will be an alarm when the condition is true, which means the alarm output will be energized and there will be a message on the display, but it won't actually lock out. So shown here are the displays when the generic input is active and the go-to action is set for standby or alarm. So here in standby, if our generic input is not true, it'll say forced IO1, and that's why it isn't starting, because the input is not true. And if we set it for alarm, then it'll say alarm instead of forced. It'll say alarm IO1, and that is why it isn't starting. But notice it's not locked out, but you do have the alarm output is on. So this is what's shown when the generic input is active and the go-to action is set for lockout. You'll have a lockout, and the lockout message will be, say, forced IO1. And again, the IO1 would be whatever the input number it actually is. So having said all that, the best use for generic inputs can be for enunciation. So the digital inputs can be used for enunciation if desired and enough are available. And this would be like a first out type enunciation. So the typical way to configure would be as follows. You would pick the use to be generic. You'd pick the assignment to be the profiles you wanted to apply to. The action would be set to either and or. It doesn't really have any effect for generic. For state, you would pick after pre-purge. For input state, you would pick 0 because you want the lockout to occur if there is no voltage. And then for go-to, you pick lockout. So the limit should be wired so the limit string still connects to the recycler safety limit input, but the status of each connection is monitored at the digital inputs. The lockout for the generic input will occur before the lockout for the safety limit input. So the lockout message will read forced IO1, forced IO2, or whichever input is applicable, and then you would know where that connection is made to determine which limit input has caused the lockout. So digital outputs. Now, digital outputs only apply to the NXF4000. And I didn't mention this before, but at the bottom of each slide, it tells you if it applies to the NXF4000, PPC4000, or both. Some of those digital inputs on the previous slides didn't apply to the 4000. Most of them did. Digital outputs only apply to the 4000. So to program digital outputs, there's a menu called User Output Setup for the NXF4000. If you press the right arrow or next key, you enter the menu, and each user output will then have a separate submenu. This is very similar to how you would program a digital input. So status uses. There are multiple choices that reflect different statuses. For some of these, assignment is used to select which profiles this output will apply to. Some of the choices are always on. The output is energized whenever the selected profile is active. Mirror input 1 through 15. The output is energized whenever the corresponding digital input and selected profile are active. Flame on. The output is energized whenever there is any flame signal and the selected profile is active. Lockout. The output is energized whenever the control is in lockout, regardless of any profile selection. Low fire. The output is energized when the modulation rate is below 6% and de-energized when the modulation rate is above 11%. The selected profile must also be active. And high fire is similar to low fire. The output is energized when the modulation rate is above 93% and de-energized when it is below 88%, and the selected profile must also be active. We also have alarm uses for the digital outputs. The alarm relay is normally energized whenever any alarm is active, but certain alarms can be decoupled from the general alarm relay and tied to a dedicated output by assigning it to a user output. Assignment is used to select which profiles this output would apply to. So first is marginal 1, marginal 2, marginal 3, or marginal all, which means the output is energized whenever the marginal input for the selected sensor or any sensor follow selected is true, and then the selected profile is active. Marginal is a set point that you enter in the set point configuration that picks a temperature or a pressure at which, when you're above that, the output is true. So it's like a high temperature, a high limit alarm. O2 trim limit is the next choice. The output is energized whenever the programmed O2 trim limit is reached and the selected profiles are active. High flue temperature. The output is energized whenever the programmed O2 system flue temperature limit is reached and the selected profile is active. O2 probe limit. The output is energized whenever the programmed O2 probe limit is reached and the selected profile is active. And then all limits, the output is energized whenever any of the above limits are reached and the selected profile is active. So we have state on off is another choice for digital outputs. The alarm, the relay is energized whenever the on state is reached and de-energized whenever the off state is reached. So each are assigned individually and they cannot be assigned to the same state. So you pick a separate on state and a separate off state for each relay. So assignment is used to select which profiles this will apply to as well. So the choices for the on and off states are listed here: standby, wait for profile, gas valve proving, steps 1 through 4, move to purge, purge, move to ignition, PTFI, pilot, MTFI, MFEP, move to low fire, auto, post, purge, and lockout. So for example, you could pick for a relay to turn on at PTFI and then turn off at MTFI, and it would turn on when it got to PTFI, turn off when it got to MTFI. You just can't pick the same state because it can't turn on and off at the same time. So for analog inputs, now this applies to both NXF and PPC4000s. There are 5 sensor inputs, and each accepts 4 to 20 milliamps and can be used for different specific functions. There's a menu called Sensor Setup for the NXF4000 and PPC4000. So you press the right arrow or next key to enter the menu, and each sensor then has its own separate submenu. The first thing in this menu is the units of measurement. So the first menu option in the Sensor Setup menu is going to let you select the units, and the 2 choices are English and metric. So in order to change the selection, this is important, all of the sensors must be set to unused. So if you try to change this and it isn't changing, you first have to set all the sensors to unused, as this is a global setting which applies to all sensors, and then you can change it from English to metric or the other way around, and then reset up the sensor. English uses PSI for pressure and degrees Fahrenheit for temperatures. Metric will either use millibar or bar for pressure depending on the resolution of the sensor, and it will use degrees Celsius for temperatures. So the options for sensor 1, which are here. Sensor 1 is used for the primary control variable, the PCV, and it is used for set point 1 and can also be assigned to set point 2 using a digital input, so you can quickly swap between the 2 set points. Sensor 1 can be set to one of 3 options. The first is steam, and this uses a steam pressure sensor in one of the following defined ranges that are all listed here. The next choice is water, which uses a water temperature transmitter in one of the defined ranges listed here. And the third choice is track, which means it uses an external 4 to 20 milliamp firing rate signal. The range is not used for track, so you don't have any choices with track modulation. Sensors 2 and 3 input options are here. So sensor 2 is used for hot standby with track modulation or sequencing. It can also be used to monitor a temperature or pressure, and a marginal alarm value can be assigned. Sensor 2 can be set to steam, and you have the same choices as with sensor 1. Water, same choices as sensor 1. And standby, which has the same choices as water. So standby would be 2 temperature transmitter options. Sensor 3 is used to monitor a temperature or pressure, and a marginal alarm can also be assigned. Sensor 3 can be set to steam with the same choices as sensor 1. Water, same as sensor 1. Outdoor, stack, or inlet, and all of those have the same choices of sensor ranges as water. Sensors 4 and 5 are used to monitor temperature, so either sensor 4 or sensor 5 can be set to inlet with the following range choices. And if the control is being connected to a supervisory system such as BMS or a PLC, the raw data can be read using Modbus and converted using a formula which is in our Mod-4001 bulletin. Any type of 4 to 20 milliamp sensor can be connected in this way, and the raw analog data is available whether the sensor is configured or not, and can be parsed in the supervisory system into some meaningful format using the formula to convert the raw data. If the control is being connected to a supervisory system, it can be read using Modbus and converted using the formula as I just mentioned. So any type of 4 to 20 milliamp sensor could be connected in this way. So for example, if you weren't using sensor 3 on the control, you could still connect a 4 to 20 milliamp device to sensor 3, read the raw analog data through Modbus, and actually make a meaningful value out of it. As long as it doesn't have a type assigned, you won't see it on the keypad on the 4000. For sensors 4 and 5, the raw data is available as long as the sensor has a type assigned. So once read, the raw data can then be parsed into a meaningful format. So lastly, we have analog outputs. So the first thing analog outputs are used for is status. So there is one analog output available on the control, as well as 2 additional when fitted with the NXCES-VFD card. Each puts out 4 to 20 milliamps and can be used to represent different data. The availability of the outputs on the NXCES-VFD depends upon whether they are being used for VFD feedback. There's a menu called Analog Out Setup for the NXF4000 and PPC4000. So you press the right arrow or next key to enter the menu, and then each output will have a separate submenu. So the choices for analog outputs can be set to represent one of the following in the ranges specified. So the first thing you can choose to represent is the modulation rate, and the 4 to 20 milliamp will represent 0 to 100%. You can also choose to read the current set point, or you choose set point. It'll read the current set point, whether it's set point 1 or set point 2, and it's going to be in the same range as the sensor. So if you have a 0 to 200 psi sensor and you're reading 12 milliamps, that means your set point is 100 psi. You can have it read sensors 1 through 5 in the same range as the sensor. So that basically means whatever 4 to 20 milliamp signals coming into sensors 1 through 5, it's putting out the same 4 to 20 milliamps on the output. You can read the positions of servos 1 through 10, and that's going to be scaled in 0 to 100 angular degrees. So a signal of 12 milliamps would represent 50 angular degrees. You can read the O2 if you have an O2 trim system in 0% to 20.9%. And that's all for the analog output. So in conclusion, you can improve your installation with all of the programmable inputs and outputs available. It is often, with all of the programmable inputs and outputs available, it is often, I said impossible, it is often possible to improve the customer experience at only the cost of the time and wiring involved. Using the inputs can help with troubleshooting no-start issues, especially if you do enunciation. And using the outputs can help with interconnecting devices as well as with supervisory systems. When also considering what is available with Modbus, a way can usually be found to connect your device or to get any information you need whenever you need it. So thanks guys for listening in, and I will hopefully send out an invitation for next week soon. So thanks for taking the time, and have a good rest of your day.